A very good morning to all of you. I cordially welcome you all for this engineering thermodynamics course. So today self-learning topic is reversibility and irreversibility concepts. So this is the self-learning topic number 5. So the motivation here is it is essential to know under which condition a process leads to a reversible process and an irreversible process. And what is the outcome of this lecture is, so you should be able to explain the conditions under which a process leads to reversibility and irreversibility. So first of all, how can we define a reversible process and irreversible process? So that is, a reversible process is defined as a process that can be reversed without leaving any trace on the surroundings. So that is, both the system and surroundings are returned to their initial states at the end of the reverse process. So in a nutshell, just I want to tell one thing. In a reversible process is nothing but the initial state is restored back after completion of the process along the same path. That is the 1 to 2. It is the process. Next 2 to 1 also, that is followed according to the same path. It is coming back to its initial position. And similarly in the reversible process, so the deviation from the equilibrium states is very small. Whenever the 1 to 2, the intermediate points are there. So these are always, they are on the equilibrium points. So it is nothing but is a locus of all equilibrium states are joined by a continuous line, then it is known as a reversible process. So if you want to attain a reversible process, it has to be carried out at very extremely slower pace. Slower rates only the process is to be carried out. So then only the deviation from the equilibrium states will be very limited. So that's why we can predict the reversible process. And coming to the irreversible process, so because we cannot join all these particular the equilibrium points because the deviation from the equilibrium points is very high. So you cannot join all these intermediate points by a continuous line. So you can join, it can be only by a dashed line, not by a continuous line. So that's why whenever you are drawing a property diagram, so it is very important one that, so if you are representing a process 1 to 2 by a continuous line, then it is a reversible process. And if it is by a dashed line, then it is an irreversible process. So that is the main difference. So the reversible processes cannot be obtained in the actual practice. So all the spontaneous processes are basically leading to an irreversible processes only. So here we have to study. So what are the reasons why the spontaneous processes are leading to the irreversible and why it cannot be possible to obtain the reversible process in the actual practice? So that is, so normally the reversible process is not at all possible due to the presence of the friction. So that is whenever you are walking, whenever you are running, whenever you are swimming, that is whenever you are doing any work, so we have to overcome the friction. But in the reversible process, we are assuming that it's a frictionless process. That is the ideal, is a hypothetical. So in the hypothetical and the ideal process, we are assuming that it is a frictionless process, but always there is a friction will be presented. So due to which the reversible process cannot be obtained. And similarly, the heat transfer is also taking place through a finite temperature difference, not by infinite temperature difference. If the heat transfer is taking place through an infinite temperature difference, then it can be treated as an example of the reversible process. But is it possible? No. So always the heat transfer is taking place according to the finite temperature difference. So that's why it is leading to an irreversible process. And similarly, is it possible to have the electrical circuit with zero resistance? No. So always whenever we are having electrical circuit, so it has to overcome the resistance. So the electrical circuit with zero resistance, that will give you the example of the reversible process. So it is not at all possible. And similarly, the unrestricted expansion, unrestrained expansion. So that is not at all possible. So due to all these particular the reasons, that is due to the presence of the friction, due to the heat transfer through a finite temperature difference, and due to the unrestricted expansion is not all possible, and electrical circuit with some amount of the resistance. So due to all these particular the reasons, all the spontaneous processes are basically leading to the irreversible process. So when the reversible process is not all possible in the actual practice, then why we have to focus so much on the reversible process? Why we have to study the concepts of the reversible process? So that is to answer such question. So we know that the devices are basically classified into work producing devices and work consuming devices. So if you want to predict the performance of any engine or the any device, whether it is a work producing device or consuming device, so it is possible only if you analyze the process according to the reversible process. That is, whenever a car is working, so normally the manufacturer will give you the advertisement in the beginning that, so this particular car will give you some 25 or 26 kilometers per liter. And he will give you some 2-star marks also. And below which very small letters he will write down under the standard test conditions and conditions applied. So what do you mean by the conditions apply or the standard test conditions? That is, whenever that particular the car is running under the frictionless conditions, that is the simulation. In the simulation process, the frictionless conditions are created. So in that particular the frictionless conditions, whenever that particular the car is running at a particular speed also, because whether it is you take the motorbike or any car also, so he will give you the economy zone, that is up to 40 or 60, let us say that up to 60 kmph. If you drive that particular the car or bike, so that it will give you some mileage. So if the speed of the engine is increased beyond the 60 kmph, then the mileage will gradually decreases. So if you want to predict the maximum mileage which can be expected from a car or bike, then that particular devices has to be operated under this particular the simulated conditions of the frictionless condition, that is the reversible conditions. So that's why it is very important. And similarly, if you want to run, that is the work consuming devices like compressor, fan, pump, blower, refrigerator and air conditioner. So this will work only whenever you give some amount of the electrical input or the work input only. So that is, they have to take less amount of the work input. So that should be the ideal case. So that is, what should be the minimum work input which is needed to drive the compressor, pump, fan or blower or the refrigerator or the air conditioner. So that is important one. So to predict the performance of this particular work consuming devices. So that's why the reversible process plays a very important role, even though it is not at all possible in the actual practice, but always our attention is basically focused on the reversible process. But some of the processes we are treating it as a quasi-static process. That is, a quasi means almost, static means uniform. So the quasi-static process can be treated as an example of the reversible process. So here I'm able to differentiate some of the points based upon the reversible and irreversible process. So the process is carried out infinitesimally very slowly in the reversible, and automatically it will take the more amount of the time, and the work obtained in the reversible process is very maximum, and the deviation from the equilibrium states is also very less. So like this, we are able to differentiate the reversible process and irreversible process, and we are able to study so under what conditions so we are able to get a reversible process, and why all the spontaneous processes are leading to an irreversible process. So thank you one and all for listening this important lecture about reversibility and irreversibility concepts. Thank you.